Hello there and welcome. So now that we have our basic server, we want to be able to access it from our Unity project. We already saw that we can access it from a browser, but in a Unity project, it's a bit different because we want to do it via the code. So we are going to first create a new project. It will be a very simple project, a very simple game, and obviously in your case you're going to have your own game. So for this tutorial I created a very simple Unity project with a game inside, and this is a clicker game, so you can simply click on this button and it will increase the score. The setup is very simple. We have the canvas and all the UI elements inside. We have the background, then we have the clicker button. Inside we have the score text, then we have a timer text, we have a start button, and we also have a high score text. And this is the entire UI. Then we also have an object for the game manager with a game manager script on it. And we have an API client object with an API client script. So the game manager takes care of all the logic that is related to the game, and the API client is responsible for the actual connection to our server. Now the focus is not on this game. I am going to explain to you how it works just so you understand that there is nothing too complicated about this. But if you want to recreate this entire scene, I'm going to provide both of these scripts in the description. So you simply create an empty object named API client and you drag this API client script on it, and you also create a game object named game manager and you drag the game manager script on it. Now don't get confused that you see this gear over here. Every time we name a script game manager, it simply changes the icon. So this is just a simple script, okay? Don't get confused. Now for all of these references, I simply dragged all the elements from the UI. So for the score text, we have the score text, then we have the timer, we have the clicker button, the start button, the API client. So we need a reference to the API client, and for the high score. So this is a very basic setup just so you understand how we can connect to the server, how we can send data, how we can get data. So first, let's just understand the logic of this game. Inside of the game manager script, inside of this game manager, we simply have the references for all of the UI, we have a reference for the API client, we have some values for the score, the timer, the initial timer, so you can set up the timer over here, and we also have a bool to know if the game is active. Now in the awake method, we simply set the on-click listeners, and then we have this method over here to get the data from the database, because when we start the game, we want to have our high score. So this is basically a method that goes into the API client script and gets data from the server. So we're going to cover this when we go over the API client script. Then when we start the game, we basically reset all the different values, all the different counters, and in the update method, as long as the game is active, then this timer will go down. We're going to update the UI, and if the timer reaches 0, it will end the game. And we also have all the different methods. Start new game, we basically reset the game. We make the clicker button interactable, and we set this bool to be active. So when it's active, then the timer will start counting down. Then we also have this on clicker button clicked. So when we click on the button, it will basically increase the score and it will update it on the UI. And eventually we use the score to be the final score. When the game is ended, we're again going to retrieve the high score, because over here we retrieve the high score when we first start the game, but we can play multiple sessions during the game, so each time we end the game we want to get the newest high score. Then we set the clicker button to be uninteractable, we stop the counter, and we check if the score for this game is higher than the high score that the player has, and if it is, then we're going to create this save data object, and we're going to set the player ID and the score, and we're basically going to send it to our API client, in order to send it to the server, okay? And if the high score is not beaten, then we're simply going to print this high score was not beaten. And then when the game ends, we're simply going to reset the game. So we're going to set everything to false and basically reset all the counters, and it will wait for us to click on the start button. Over here, when we create the save data object, we also want to get some kind of player ID. So each device will have its own player ID. So if you play on your computer, it will have its own player ID. If you play on another device or on your phone, you will have another player ID. And we need this in order to actually have some kind of reference to the score. So when we save the score in the server, we want to know to which player it belongs, obviously. And the way we're going to create this player ID is by creating a device unique identifier. So it basically creates some kind of identifier based on your computer. So it's usually something long like this with numbers and digits. For each device, it's a bit different, but the point is that it will always create the same identifier for the same device, okay? So you don't need to worry that tomorrow it's going to create another identifier. As long as you play on the same computer, it will always be the same ID. Now, of course, we can create this identifier once and then save it into the player pref, but this is something you can do. This is not the point of this tutorial. Then we also have this callback that basically is called when the data comes back out from the API client. Now, I'm not going to cover callbacks, but a callback is basically a way to get information from an asynchronous task, okay? Because usually we can simply create some kind of method that will return some data, and then we can return the data out of the method. But if it's something that is related to connection to a server, we are not going to do it in a regular way. We're going to use an asynchronous operation because we don't want to block our actual program. We want to wait until this happens, and we don't know when this will happen. Maybe you have a bad internet connection, so it will take a bit longer to get the response, right? We cannot know when you get the response. With a regular code, you know that this line will start running and then another line and then another line, and it will basically happen one after another. But when we send some information over the internet, we don't know how long it will take. So we cannot get data back if we don't know when the data will be available. So for this, we use callbacks and basically say when the data is ready, when the data is back, we are going to receive it. And I'm going to show you how we actually use this callback. But when the callback is returned, then we're simply going to get the saved data from the server and we're going to display it on the UI, okay? And this is basically a way to load the data. And we also have both of these methods to update the score UI and to update the timer UI, okay? And you're going to get this entire script so you can recreate it on your own computer. Now let's go over the API client. The API client is just a script that handles the connections to our server. In our example, we are only dealing with saving data and loading data. But imagine that we can do other operations, for example, get a list of all the users for some kind of leaderboard screen. Maybe we want to delete user information on the server. So we can do a lot of things in Unity to affect the server. We can get information from the server. We can do whatever we want. So all of this data should be inside of some kind of API client. In our case, we are only dealing with saving data and loading data. So we have this class, this save data class that contains the player ID and the high score. Obviously, in a bigger game, you will probably have a much bigger class that will contain positions and much more information to save the entire game. But in our case, we only have a player ID and we have a high score. Then we also have these constant strings, which are the server base URL and also these different endpoints. And we are going to fill this in a moment, but you can already recognize this from our endpoint script. So we're going to have an endpoint to save the data by setting the data and getting the data. So you remember, these are the endpoints that we created on our endpoint service. And now all we need to do is fill in the base URL, and we're going to connect both of them and get the full URL. Depends on the operation that we want to do. Because if we want to get the data, we're going to basically take the server base URL and add the save endpoint to it. But if we want to get the data, then we're going to set the base URL and add the load data endpoint. Okay, so instead of doing it twice, instead of having the base URL with the set data and then another one, we simply split them and then we use them. Because again, maybe tomorrow we are going to add more endpoints. Maybe we're going to have some kind of API get users or API check health, the same one that we already have. I think it's health, something like that. Maybe we want to check if the server is online before we actually get the data. So we can create many more endpoints on our server, and we want to separate them and not have them all in one block. Now again, we're going to fill this out in a moment. Then we have two of these methods that are public methods that we can access and basically save data and get the save data. We can rename this to get save data, okay? And inside this save data, we basically provide the save data that we created. Remember, in the game manager, when the game is ended, we create this object, we insert the player ID and the score, and we send it into the API client. So this is this method, and this is the method that is used to get the data, to load the data from the server. And this may look weird. This is basically the way we send a callback, okay? And a callback is basically a method that we send into another method, and then we send it to the actual code, and we can set some information into this method and return it back. So again, this is not a tutorial about callbacks. You can learn a bit about callbacks if this is something new to you, okay? And this is not so beginners friendly. Usually beginners don't work with callbacks, but basically we just send some kind of method into this method, and then we do this once more because this is a public method and we don't want to have access to this private method, okay? So then we send it again into this private method, and then this private method simply gets this callback. And then when we finally receive the data, we can invoke it and send the save data into the callback. And then it will basically run this method over here because we said invoke, right? So when we say invoke, it will basically call this method, and this method will be called, and we're simply going to display the high score because now we got this data. Again, as I told you, we use callbacks when we don't know when the data is going to be available, okay? So this method simply creates a web request. It uses this Unity web request class, and it uses this get method. So exactly like in our examples, when we entered the full URL in the browser and we got the information, over here we basically do the same thing. We provide the URL and we perform a get request, and then we can simply build this request over here. So after we build this request, we use yield return because we want to do this asynchronously, because when we send this web request, we don't know when the data will be available. Again, as I told you, You may have some kind of busy server, you may have a slow internet connection, so you don't know when the data will be available. And that's why we use this yield return, which is available because we use a coroutine, and it basically stops the code from running. Because in a regular method, the code runs one line after the other, right? This line, and then this line, and then this line, and then this line. But over here, we basically stop the code. So the code will wait until this is sent, and then we have some kind of response. And only when we have a response or a result, then it's going to continue, okay? And that's why we use this coroutine and we use this yield return. It will basically wait for the response, okay? So when we have the response, we're going to continue and we're going to check if this response, this result, is actually successful. And if it's successful, then we're going to use this download handler to get the text, which will be the JSON, okay? And you remember, we are getting a JSON from this get data endpoint. This is exactly what we created on our server. Then after we get this JSON response, we're going to use Unity's JSON utility to convert the JSON into an object. So the JSON will be exactly like this save data object, and we're going to convert the raw JSON, this string, into this save data object. We're going to create a new object, and then we can print it. But what we actually want to do is send it back to the UI. And in order to send it back to the UI, we're going to send it into the callback. So if this is something new for you, if these are new terms, please learn a bit about asynchronous operations. These are usually the operations that we perform when we are dealing with networking, with web requests. So you should know about this. And then when this is invoked, we're simply going to call this method over here, and it will basically run this, and it will update the UI. Now, this is basic knowledge as far as network requests, okay? So this is not something new. This is not the point of this tutorial. Even this is not the point of this tutorial. The point of this tutorial is to create a server. So if you never dealt with servers, you never used Firebase or Firestore, you never connected to an online database, this is an additional thing that you should learn, because this is not what this tutorial is all about. This is a regular way we create web requests. If you ever needed to create some kind of weather application and you wanted to get some kind of weather data from an API, you would do the same exact thing to get data from an API, okay? So this has nothing to do with servers. This has nothing to do with a custom server. This is just a way we get information from the internet. So I hope that this doesn't confuse you, especially this callback thing, but now we're going to get to actually getting and sending information to our server. And eventually you can just copy this entire script and input your own IP, okay? And then you will be able to send and get data. So if you don't want to learn all of these things, it's okay. I'm just going over this entire script so you know how it works. Now we covered the getting of the information, the loading of the information. Now we're also going to do the same thing for saving the data. So for the saving, we basically do almost the same thing. We send the save data as a parameter. We convert it into a string. So over here, we do the opposite, okay? Instead of taking the JSON and converting it into an object, we take the object and we convert it into a JSON. Then we use the same web request, but this time we use a post request, because by using a post request, we can send data to the server. this is for sending the JSON to our server, okay? And this is for fetching or getting the JSON from our server, okay? So you can add these comments so it will be a bit clearer. And again, over here, we send this request. We basically send the save data JSON to this URL, but this time it will be into the save data endpoint. And then we need to convert the JSON into a byte array just in order to convert it to actual data, right? Ones and zeros. And then we send it and we upload it. Then we also need to download the response, because usually when we send some information to the server, we need to get the response to know if it was successful. So we also get the response over here. And we also need to set the header. This is just something we have to do because we basically say this is a JSON file, okay? We need to let the server know that this is a JSON file. So we set this header over here. Then again, we wait for the response. And even though we are sending data, we still want to wait for the response because we need to know if it was successful, right? And if it was successful, we are simply going to print it and the debug log. But if it failed, we're going to print the error, okay? So over here, we don't need a callback because we don't need to do anything with the data. We saved the data in our database and we simply got some kind of response. So we only need this for debugging. And this is basically it. This is the entire script that handles this connection. Now, again, this is about saving and loading these JSONs. You can add more methods that will basically get some kind of list of users, and we'll probably do this later on in this series, okay? Now we need to input this base URL in order to actually connect to our server, right? So let's open our AWS console. Let's start our server. Obviously, if it's not running, we cannot connect to it. We're going to start it. And because we have a service, we know that we can connect to these endpoints. And we saw that we can do this from the browser, right? We can take the public IP, and remember, this public IP is always changing when we stop and start the server. So this is a new public IP. We're going to add it into our URL bar, and we're going to use port 5001, and we're going to use our API health. And we can see that the server is online, and it makes sense because the server is online. Now, we can also go into this get JSON endpoint, and not get JSON, I'm a bit confused, get data, and it's going to say that the data is not available. And this makes sense because we don't have a JSON yet on our server, right? If we go to our server, if we connect to our machine, and we do ls, and then we go into this folder, and we do ls again, we only have our simple endpoint, and we have our test1 file that we used in the previous tutorial to show you how we can use SCP, right? We don't have any JSON over here. Now, if we do cat and our Python script, we can see that inside of the script, when we want to get the data, what it actually does, it goes into this method, loadJSON, and this loadJSON method is this method over here, loadJSON, and it will basically look for this file, this JSON file over here. And if it exists, then it will simply return it. If it doesn't exist, it will basically return nothing. It will tell us that there is nothing over here. And this is exactly what will happen because we don't have any file yet, okay? Now, on the other hand, when we set the data, when we set a JSON, then it's going to use this save JSON method, and this save JSON method simply creates a file with this name, okay? So the first time we're going to send the JSON to our server, it's going to be created, and then we can also get the JSON back. But right now we cannot get the data because we don't have any JSON on our server. So if we go back to the script, if we use this get data right now, it will basically tell us that there is nothing on the server. And when we set the data, we are going to be able to create a JSON and then later also get it. Now we need to set the base URL. So let's copy all of this. Okay, let's go to our script and let's paste it inside. And you see that this appeared automatically because it's a part of the URL. And this is our IP, the public IP. So in your case, you will have to find your own public IP. You just go to your instance and you copy the public IP of your machine and you paste it inside. And we're using port 5001, and this is the endpoint. But because this is just the base URL, we're going to delete this part and we're going to use this endpoint. So just remove everything up until this slash. We still need this slash over here because we don't have it over here, okay? And what it basically does, it connects both of them together, right? Server base and load endpoint. It basically takes this thing and it adds this thing. Okay? So that's exactly what we are doing. We're getting the full URL exactly like we have over here. But in our case, in Unity, we're simply splitting this up. So now we have our base URL because this will not change. What will change is the endpoint. When we want to load data, we're going to use this one. And when we want to save data, we're going to use this one. Okay? And now that we have this, we can actually start and test the game. So we're going to save this script. We make sure that all of these references are over here, and we're going to run the game. Now, when we run the game, the first thing that is going to happen is this awake method, of course, and it will try to load the high score of this user. But because we don't have a JSON yet on the server, what will happen? It will return this no data available, and it will give us this 404 response code, which means not found, okay? And we are going to see this in Unity because we still don't have a JSON the first time we run the game. Now, in the previous episode, I showed you how we can use the journal.ctl to get information about our service. So let's do this. Let's use sudo journal.ctl f because we want to follow the logs in real time, and then u because we want to provide the name of the service, simple endpoint service. And these are the logs. Now again, this part over here is blurred because this is my home IP, but we can see that we try to do some calls to our API. So this is from before. This is when we tried to do it in the browser, okay? So now when we're going to do this from Unity, it's going to get updated in real time, and we're going to see all the different operations. And even here, we can see that we tried to get some data, the JSON, right? And it gave us 404 because we don't have any JSON available, and this is exactly what should happen. So now in our game, let's start the game. And first of all, we're going to see this error over here that tells us that non-secure connections are disabled in Unity. And what it basically means, it means that we cannot use HTTP because it's not secure, right? We need to use HTTPS, that's fine, but our server doesn't have HTTPS, it only has HTTP. So Unity will not allow this connection. Now obviously we're going to fix this, but just know that in the future we're also going to allow HTTPS connection to our server. So we're going to make our server into a more secure server. We're going to add HTTPS, but for now we don't have this. We can only connect to our server via HTTP. So we're going to fix this problem in Unity. And the way we're going to fix this is by going to the player settings, because it tells us the non-secure connections are disabled in player settings. So we're going to stop the game, we're going to open the build settings, then player settings, and inside we're going to click on player, scroll down to other settings. Okay, it's going to be closed, we're going to open it, we're going to scroll down a bit, and over here you can find allow downloads over HTTP. So the default is not allowed. So we're going to turn it to always allow. Now it gives us a warning because it says that it's not secure, people can hack us, people can exploit us, but we don't care because this is just for testing. Later we're going to change it to HTTPS. So we're going to allow this, we're going to close this entire thing, and now it's going to allow us to connect to the server. So now we run the game, and we're going to get this 400 not found because we don't have any JSON on the server. And we can also go to the server and we can see this new log over here. And this is the log from our connection. And this is exactly the error that we got because we don't have a JSON yet. So only after we start a game and we end the game and we save a JSON on the server, only then we're going to be able to get this JSON. So now we're going to start the game. To start the game, we simply click on start. The counter will start to count down and we need to click on this button as much as we can. I'm not going to do my best because I want to beat the high score later, so I'm going to keep it at 34. And now the game is over and we can see over here, data successfully sent. We basically sent this information, our user ID and the high score, to our server. And now if we go to the server, we can see that we used this set data endpoint using a post request and we got 200, which means okay. It means that this was successful. And we can see all of this in our logs. Now, what happened on the server? We basically created a JSON file on the server. So if we press on Ctrl+C to exit these logs and we do clear, just to clear everything, and we do ls, we can see that we have this new data.json file in our folder. And if we do cat data.json, we're going to see the content of this JSON file, which is my device ID. Okay, so this is my home PC ID and the high score, 34. Very, very simple, very straightforward. There is nothing too complicated, but this is the base for all connections to a server. We basically send information, we save it on the server, and then we can also get it. So now that we have this file over here, we can use the get data endpoint. And if we try to do it from the browser and we refresh, we can get this JSON. And now, if we go to our game, and when we start the game, it will try to load the data. Okay? And what we should expect is to see 34 over here. So let's start. And this is exactly what happened. We have the high score of this device. And we can also see data received from API, and we have the high score. Then if we go to our server and we do sudo, let's just press up, we can see that we used again this get data and we got 200. Okay, so everything is working. We are saving a JSON and we are getting the JSON over here. Right? We get the JSON and then we simply convert the JSON into this class, and then we use this class to display the high score. It's very simple, very straightforward. So all you need to do is basically just change the public IP. And of course, later we're going to add more functionality, because if you noticed, we are going to get a problem, because at this point we only have one JSON. It means that we can only save the high score of one user. But what if I have multiple users? What if I have more devices? They will all overwrite this JSON file. So obviously this is not a good approach. We need to create multiple JSON files, basically a JSON file for each user. And then when we try to load the high score, it will load the JSON for this specific user. So don't worry, we are going to do this in the next episode. Now, another thing that I want to show you is that, for example, you're testing your game and you want to delete this high score. You don't want this anymore. Again, it's a good thing that we have a custom server, because you can simply delete this file. In order to delete a file in Linux, we simply type rm, which stands for remove, and then the name of the file. And this is a very dangerous command because you can actually delete important information by just using this very short command. So data JSON, and that's it. The file was deleted. I can do ls, and it's no longer over here. Let's also delete this test1 text because we don't need this. So again, rm test1 text. No, not tet, text. And now we don't have this anymore. We only have our simple endpoint. So that's all I want to show you in this episode. I know it got a bit longer than the usual ones, but that's just because we really had to go over this entire project for you to understand. And again, the point of this tutorial was not about the game logic. It's not about the API client, because this is something we usually do with every web request, but it's just the understanding that we can send a JSON to our API and we can get the JSON back. And it's a good thing to add all of these comments because it can really help you understand what the code is all about. Now, another problem that we will encounter in the future is that if for some reason you decide to stop the instance, right? And then start it again. Let me just show you. Let's stop this instance. And then I want to start it again. Let's go inside. And now we have a new public IP. So if we copy this and we go to the script, it's not the same IP. So when we start the server again, this will not work. This will break because your game has the wrong IP. And if you have this game on other devices, on your user devices, they will all fail to connect to the server. So it will break the game. So this is something we need to think about. Now, obviously, there is a solution. AWS is a professional platform for these kind of things, so it will be resolved. We have two different options, and I'm going to show this in a different episode, so don't think that it's something that I did not think about. We're going to have a way to actually have persistent IP addresses, and we also have a simple workaround by creating a backup or a failover server. So if we fail to connect to this IP, it will go to a failover server and then it will get the new IP. And it's a cool trick, but I'm going to show you how to do this. So that's all for this episode. Again, I'm sorry that it was very long, but I just want to cover this entire thing in one episode. In the next episode, we're going to see how we can create JSON files for each user. So thank you for watching. Please subscribe if you're still not subscribed. You can share this video. You can leave a like for the algorithm. And I'll see you next time.